The Catawba River Basin is the first, actually in North America, to actually join together as a basin, the utilities themselves, and jointly work on non-revenue water. And it really was starting from scratch as they did that. So a little bit about the basin. You might call this a cross-border cooperation, and because it straddles two states. It straddles the state of North Carolina and the state of South Carolina, which is a political boundary, obviously. We have two different jurisdictions that are there for the water utilities, but one common aspect is the river basin itself. And this is going to become important as I talk this through of the 18 utilities. There was a major utility, many of you have heard of Charlotte, North Carolina. This was a substantial user, but there was also one of the major power plants that used cooling water from this particular river basin. Duke Energy is in this basin as well. So there needed to be a common way of looking at use and loss, and they did a number of things. It was not just non-revenue water, although that's what I'll be speaking about, but it was really in looking at total efficiency of the water resource and paying attention to that water resource. In this case, this is a limiting factor. The growth projections of the city of Charlotte and the number of utilities, the other 17, over a 50-year period is a substantial shortage that would be coming if they did not manage their use and loss. So in looking at it, some of you saw this before. This is the stepwise process of creating water balance, validating that information, really leaning in, and then breaking down those losses, real and apparent, and digging deeper and looking at the technical analysis. What can we get at when it actually in turn is determined that it makes sense for us to do that financially? And then from benefit cost, being able to show the utility itself that builds the momentum that we allow to put together the improvements plan, the capital that's needed, the investments that are needed for revenue recovery aspects, and then obviously implementing. What should we be implementing and doing the 4 steps that we're looking at? So in this case, each of those 4 steps for this river basin, they've embarked on each of these steps together, which is a very, very powerful thing. And where they have started, obviously, was the water balance. We've seen this. They also use the free water audit software. They have formulated their team, so instead of being the water audit guy or the water audit gal that is responsible, it's actually bringing all of the departments together, the teams that it takes, billing, distribution, supply, everyone that has an impact and a relationship in the management of non-revenue water into this technical assistance and training and really wrestling with that data. But it's not just doing the water balance, it's also taking those next steps of looking at where do we have inherent challenges with the data that we have? How do we further break this down doing the leakage component analysis? Of the leakage that we have out there, and we start to do those bottom-up activities, how much of that is in a background fashion? How much of that is reported breaks that we're tracking through our work order processing system? And these utilities came from the broad spectrum. Some were not really even tracking their breaks. They were breaking it down between mains and services. There's a lot of education, and there still is a lot of education for those utilities to start gathering the data, to start working through if it's their work order processing system or maybe even starting a work order processing system. Have they been estimating the leakage volumes as they've been repairing those leaks out there? In many cases, a lot of education of getting started and really supporting those practices with 18 of them working together to help move across the finish line. The same on the customer meter side, the apparent losses of looking at theft, looking at the unauthorized consumption. It could be tampering. One utility, they actually had kind of a rogue employee in the meter shop that drilled the mutating disc, which magically was a corruption that was discovered through this actual project of looking at the losses. Some of these things that you heard some stories that you never really think unauthorized consumption may be that big of an issue, but in this particular case for this utility, it was. So how to put together that large and small meter testing program and look at the revenue gains that you can have from that. Obviously, focusing on the 3 V's, the volumes, the values, and the validity. We've talked about the economics of this, and so we won't rehash this, but really understanding where should each utility be operating. It's not a one-size-fits-all that Rock Hill, South Carolina is the same as Longview, North Carolina. It's where their economics are with that shared common resource that's out there. So a little bit about the program and the results now. So one of the things that I'm most excited about is the programmatic website and data gathering process and the data request and the upload function. We hear a lot, this is too complicated. Utilities aren't going to be able to do this. In reality, they absolutely leaned in and started gathering the data. And then they had a shared resource by which they see that data and interact and understand about the program. This is now in its 4th year of implementation. So this has been a continuation and improvement of that data that's out there. A little bit about the results. So looking at it, again, trying to make sure that I've got correct units. Probably shouldn't have used megaliters, but anyway, if you can follow along in the megaliters there, away from the million gallons, which is my common language, where they are as a basin. And this is important. It's something that I would really stress to the countries and maybe the regional associations that are maybe helping in each of these countries to move forward. There's autonomy that the utilities, especially if it's not a regulatory requirement, may want to have. And in this case, they did. They did not want their data, their results, out for public consumption. But as a basin, they wanted to have it rolled up and to be able to look at that data and see where they were in relationship to where the utilities and aggregation are, but also kind of max needs and so forth. So you're going to see some box plots here for these particular utilities as an aggregation. There's a slide I'll show that's each individual because they obviously wanted their data and want to be working on their plan. So to talk a little bit about the data validity score, you can see the weighted average there, that's a 63, and I haven't talked a lot about that in my presentation. I've talked about validation and the validation step. This is not you get an A in school or you get 100% in school and that's good. And it's not if you get a 50 that's bad. It's really an understanding of where they are and the way that they're tracking their data. So there's a lot of psychology that goes on in technical assistance and training of these utilities as well to realize how to communicate with their boards, to be honest about where they are. If they are not testing their supply meters, they've not done any volumetric test of that meter, they're not doing signal calibration, they've not done a chain analysis of how that information is logged from the supply meter, then they would receive a data validity score for that input into the water audit of 4 or 5. Well, that's not good or bad. It's just saying that's where they are and to make improvement over time. So aggregating all of the components of the free water audit software, again, that's the tool for this group of utilities. They landed at a weighted average of around 63, with some at 43 and some at 72. But again, not everyone at 100%. The psychology and understanding where they are as best practices was very, very critical. You can see the total volume of non-revenue water as it relates to the total volume of water supply. Again, same concepts that I've been speaking about in the past 2 days, breaking it down by volumes and values in terms of those main components of non-revenue water. Leakage, obviously, the commercial losses or apparent losses, and then how much it takes for them to operate the system, flushing and so forth. Now, a little bit for the individual utilities, and this again is an aggregation, so you're seeing all 18 in the box plot here, with the minimum, the maximum, and the averages, where they are in terms of non-revenue water, 1,000 liters per connection per year, we would say 1,000 gallons per connection per year. And then also the value, again, some of this is germane to the area that we're operating within, but the same concept. Where are they in terms of their peers in that river basin? And then looking at that of the elements of non-revenue water and consumption or volumetric basis per connection per day. And again, this is where, at least in the States, it's moving. It's moving to this normalized way of looking at the components of non-revenue water in this way. But you can see anywhere from 19 up to 60 liters per connection per day on unbilled consumption. And then on the leakage, we'll go to the other side, 151 to 303. hopefully in the Q&A, if that's something that seems in line of what you're hearing. This again is leakage, where we've broken down that leakage. I'd love to hear that in a question or a comment. So statistics for the individual utilities is blacked out or is whited out, but on the screen probably there you can see each individual utility, all 18 of those, with their action plan, their performance, with their pie chart of how it affects them individually. Again, it's not just the water balance, it's moving beyond the water balance, breaking down the losses and determining programmatically what we need to be working on. So as a basin, 28% of the leakage out there is background leakage. They're operating at technical minimums at that level, 28%. So looking at it, what they reported, what they had been tracking and building upon their records at 5%, and then the unreported, or I like to say the bogey, what we would be going after is 67% in their particular case of these 18 aggregated together, of the total leakage that's out there. In a similar fashion, breaking down large meters and small meters, for meter inaccuracy, 76% of the apparent losses are broken down as meter inaccuracy. This is fairly common in what we see from water utilities, at least in the states that are taking a close look at breaking down those losses with the technical evaluation. This is the disaggregated profile, so I'm not quite sure why that's flipped around, but this is what I'm talking about. Each individual utility has an action plan and an implementation plan. So, what are the things that we discovered in that? Well, there were some common elements of leak detection. There are common elements of meter testing. Common elements of supply meter testing. Common elements equal common opportunities, and these utilities are banding together with some contracts and being able to solicit 2 or 3 contractors to do some source meter testing and being able to move forward with some leak detection. That was shown as a model in Georgia. The state of Georgia utilities actually getting technical assistance from the state from an implementation standpoint. It's something that likely this group of utilities will be implementing as well. A little bit on the total elements of their non-revenue water and looking at both commercial and apparent losses and real losses. Again, trying to make sure that the conversion is correct, but the unreported leakage, and this is their volume in that basin that they see is worthwhile, cost-effective for them to go and discover and to locate, repair, and have as available resource water that they can sell, just to show that element. For these 18 utilities on an annual basis, that means about $3.2 billion for the basin and the utilities. So you can sort of see the breakdown, and again, that's the idea and something that they can translate pretty quickly to their governing boards of why they need to be investing what they're investing on non-revenue water management. The kind of takeaway or punchline slide, it's a shared resource, and many times we see a state or maybe a nation in this case, a country that says we need to have this standard. Well, there's so many things that are dependent on the utilities, their geographic location, the physical characteristics of the utility, pressures that they operate, and so forth. In this case, these utilities have a common resource, and so that common shared resource is their driver, and they will be setting their benchmarks for the basin, which is something I believe is a model or basin model we look at. Obviously, the collaboration perspective, we had a great cross-section of folks that had never looked at non-revenue water and paid any attention to it. We had some that had crews that were very active and engaged, doing some of the things that we heard from some of the speakers today out there with DMAs and developing their programs. So a good thing there from working together. With that, my last plug from the North American Water Loss Conference in Nashville, Tennessee. If you can make it December 3rd through the 5th, please join us there. And with that, I'll entertain a question or two. Yes, please.
I won't pay. Thank you very much. Thank you. This is a very nice presentation, I must say. Again, I have a question, a little question. I like this approach with how you did it now with this example. I'm just wondering one little detail. Have you shared results with the public?
Yes, the website you see actually is available to the public, but the individual utility results, those are not available. And this was the way that they set up, they self-funded this, they pitched in their money for the technical assistance, and it's not regulatorily required for these utilities to report this. So as an aggregation, it is available. In public, we have Freedom of Information Act in the states, and if a citizen wanted to have a copy of this information, then the utility is legally bound to give that to the citizen. But it's not published on a website for them to review.
And journalists as well can get the data?
Journalists can get the data on that same Freedom of Information Act.
Because I was just thinking, how to make a pressure on water utilities to perform better in the future. Because when you have these kind of, compared data, then you can actually push those, the weakest one, actually to do something. Because the public will say, we see now how the others have performed, so we should do something.
You've hit on